We will now find the value of this given limit. So we have a limit of x approaches 3, x f of x minus 6 over g of x minus 1. So first, I'm going to apply the quotient rule of limits, which says that limit of a quotient is equal to the quotient of the limits. So considering the numerator expression and the denominator expression, this limit can be rewritten as limit of x approaches 3, the numerator expressions, divided by the denominator expression, that is limit of x approaches 3, g of x minus 1. Now let's apply some properties of the limits. So in the numerator limit, we can apply the sum or the difference rule first. So when we do that, we get limit of x approaches 3, x times of f of x minus of limit of x approaches 3, 6. And as well in the denominator, we can apply the difference rule. So when you do that, we will get a limit of x approaches 3, g of x minus of limit of x approaches 3, 1. We will further simplify this. That is, here we can apply the limit of a product, so which will become limit product of the limits. So therefore, this expression can be written as a limit of x approaches 3 of x times of a limit of f of x, x approaches 3. And then we have the other expressions as it is. Limit of x approaches 3, 6 over limit of g of x, x approaches 3 minus limit of 1, x approaches 3. We will now utilize the table values to determine this value of this expression. So we have this limit of x, x approaches 3. Here we can make a direct substitution. So when we do that, this becomes 3 times of limit of f of x, x approaches 3. So we go back to the table. When x approaches 3, f of x equals 2. So we can utilize that. I'm going to substitute 2 over here. And then this limit of a constant, which is 6, is a constant. Limit of a constant is always a constant irrespective of whatever the x approaches. So this becomes 6 over limit of g of x when x approaches 3. So we will have to utilize the table. We look at this column, that is when x approaches 3, g of x is 1. So we can put 1 over here, and then minus of 1. Again, this is limit of 1, which is a constant. So this becomes 1. Now let's simplify this. 3 times of 2 is 6. 6 minus 6 over 0. So we get 0 over 0. So this is an indeterminate form. And when we get an indeterminate form, we will have to use the L'Hopital's rule to evaluate the limit. So now that we have determined that we can apply the L'Hopital's rule to evaluate this limit, so here we once again consider the original limit expression and find the derivative of the numerator expression divided by the derivative of the denominator expression. So I'm going to find the derivative of the numerator expression. In numerator, we have x f of x minus 6. This is the expression. So we will use a product rule to find the derivative of x times of f of x. So the derivative of x times of f of x is, when you use the product rule, the derivative of x is 1 multiplied with f of x plus we keep the x as it is and then multiply with the derivative of f of x, which is f prime of x. And we then have a negative 6, which is a constant. So the derivative of constant is 0. So we can just ignore that. And divided by, we will now have to find the derivative of the denominator expression. We have g of x minus 1. Derivative of g of x is g prime of x. And negative 1 is a constant. So its derivative will become 0. So then we will apply the limit now. So once again, we are going to apply the sum rule of the limit as well as the quotient rule. So we can write down this limit as the limit of x approaches 3. The first expression is one time of f of x is f of x, plus we then have a product expression. So I'm going to write down this as a limit of products, that is a limit of x approaches 3x times of limit of f prime of x approaches 3 over the limit of g prime of x approaches 3. Now let's utilize the table. Limit of f of x when x approaches 3, we will utilize this value, that is 2. So the first expression I put 2 here, and limit of x when x approaches 3, this is basically we have to do the direct substitution. So therefore this becomes 3, and then multiplied with the limit of f prime of x approaches 3. So we utilize this value, that is when x approaches 3, f prime of x is 7. So we can put 7 over here and divided by limit of g prime of x when x approaches 3. So now we utilize this value, that is when x approaches 3, g prime of x equals 2. So basically the value of this limit in the denominator is 2. Let's simplify this. So therefore this becomes 2 plus 3 times of 7 is 21 divided by 2. So this becomes 21 plus 2 is 23 over 2. So this is the final value of the given limit, which means we choose this option C.